Welcome back, fourth graders. Today we are on Unit 3, Lesson 2. Today we'll take a look at addition and subtraction change problems. What this means is we will be noticing a change in the problem that we will have to solve for in order to get the result that we're looking for. We have a few examples here of change problems and situations. So there may be an example of what's called a change plus problem, where we'll start with a number, then we'll need to add a change to that number, so maybe adding more, and that will equal the result or answer to our problem. Another example is something called a change minus problem, where we start with a number and then we actually subtract from that number in order to get the result. So today will be a lot of practice with word problems and figuring out if I need to add to the starting number or subtract from the starting number in order to get the correct result. Let's get started. Here we have one of our first problems to solve. I'm going to go ahead and read this problem. Please follow along with me. At the park, 6 children were playing. Some more children came to the park. Now, 13 children are at the park. How many more children came to the park? So we do notice that there is a change in this problem that we are going to have to solve for. So I noticed that at the beginning of the problem it said 6 children were playing. So I'm going to go ahead and write the number 6. Then we have a mystery number. It doesn't tell me how many more children came to the park. It just says some more children came. So I know that we're going to be adding those children to the original kids who were playing there. So I'm going to use a variable. I'm just going to say plus C, standing for this mysterious some more children. And then I'm going to write equals the result, because then it says now 13 children are at the park. So then we see that there's 13 kids there. So in order to solve for this problem, I'm going to take 13, I'm going to subtract the 6 kids who were there playing in the first place, and that will give me the mysterious C, or the more children that joined the original kids. So 13 minus 6, that gives me 7 kids. So I know that 7 children came to the park to join the first 6 to play. Problem number 2. I'm going to go ahead and read it aloud. You can follow along with me. At the park, some children were playing. Then 20 children had to go home. Now 30 children are left. How many children were at the park to begin with? All right, so we're at the park again, but our numbers are different that we're dealing with. So this one says, at the park, some children were playing. So right away, they start us off with this mystery number by just saying some children. So I'm going to represent that with a C. It then says, then 20 children had to go home. So that means these kids are leaving the park. So I'm going to be subtracting 20. Then it says 30 children are left at the park. So that's going to equal 30 children left at the park. Question asks, how many children were at the park to begin with? So I'm solving for this mystery number of how many kids were there at the park in the first place. In order to solve this, I can think to myself, well, what minus 20 would give me 30? Or I could do the opposite operation and do 30 kids that were there at the park plus those 20 kids before they went home to equal this mystery number of how many kids are at the park to begin with. Well, I know 30 plus 20 equals 50. So just to check my work, if I took 50 and subtracted 20, because remember those 20 kids left to go home, yes, that does create an equal equation to equal 30. So my answer would be 50 children, because 50 kids were there to begin with. Now I'm ready for my next problem. This one says, one afternoon, 63 books were checked out of the library. That day, 72 books in all were checked out. How many books were checked out that morning? So this one's a little bit different than the others. When I write my equation, I'll be approaching it a little bit differently. This one talks about how in the afternoon, 63 books were checked out. So 63 books. Then it gives us the result already by saying that day, 72 books in all were checked out. So I know somewhere over here, I need to equal 72. The question is, how many books were checked out in the morning? So I know I'm going to be adding the afternoon and morning books to get a total of 72 books that day. So that means I'm adding, I'll do plus B for books, to get 63 plus some books equals 72 books checked out that day. In order to solve this problem, I'm going to need to take 72, the total, minus the afternoon books, 63, to equal the morning books, which is the mysterious number I'm looking for. So I'm going to go ahead and show that work here. 72 minus 63. 2 minus 3, I have to borrow 10 from the 7. So now I have 12 minus 3 to give me 9, and 6 minus 6, which equals 0. So now I've solved for the books checked out in the morning. B would have to equal 9. To double check, I could go back to my original equation and do 63 plus 9. Yes, that does equal 72. So my answer would be 9 books that were checked out in the morning. All right, fourth graders, it's time for you to try this on your own. You have 2 problems to solve for your ticket today. The first one is here, and your second problem is down below. I'll read them aloud to you, and then I want you to get started. Number 1 says, 50 fourth graders went to recess at 11 a.m. Some more fourth graders joined them at 11:10 a.m. By the time recess was over, 75 kids were outside. How many fourth graders came outside at 11:10 a.m.? Please write an equation and then solve for the missing part of this problem, which is asking how many fourth graders came outside at 11:10 a.m. Number 2 says, 45 kids went to the beach on Saturday afternoon. By evening, 26 more kids had showed up at the beach. How many kids visited the beach in all that day? For this one again, I would like you to write an equation and then solve for the missing piece, which is how many kids visited the beach in all that day. Good luck! I know you'll do great.